Let's go to B. Check the pattern of a differential equation first. We need to make sure the coefficient of dy dx is 1. First step, divided by x squared for every single term. Dy dx plus 2 over x y equals cosine x over x squared. Then first step, p of x equals 2 over x. Q of x equals cosine x over x squared. We need to figure out this integrating factor, e to the integral p of x dx. Integral p of x dx equals integral 2 over x dx equals 2 natural log of absolute value of x. Since x greater than 0 equals 2 natural log of x. So the integrating factor will be e to the 2 natural log of x power. Make this 2 the exponent, e natural log of x squared equals x squared. Second step, use this formula to solve for y. Iy equals integral iq of x dx. X squared y equals integral x squared times q of x is cosine x over x squared. Reduce equals integral cosine x dx. We do know sine x prime equals cosine x. Both sides take integral. We get sine x equals integral cosine x dx. So we get x squared y equals sine x plus c. The boundary condition is y of pi over 2 equals 0. So we get 0 equals sine pi over 2 is 1 plus c. c equals -1. Then we substitute back into this equation. X squared y equals sine x minus 1 divided by x squared both sides. Y equals sine x over x squared minus 1 over x squared. Let's go to C. dy dx plus y over x equals e to the x squared power, x greater than 0. It's given that y equals 0 when x equals 1. Y of 1 equals 0. First step, you need to check the equation pattern. This is a pattern for linear differential equation. The given differential equation is this pattern. Then second step, figure out p of x equals 1 over x. Q of x equals e to the x squared power. We know e to the x power squared equals e to the 2x power. It's not equal to e to the x squared power. Think about when x equals -1. E to the 2x power equals e times 2 times -1 equals e to the negative second power. But for e to the x squared power equals e negative 1 squared equals e to the first power. So for I equals e integral of p of x dx, integral p of x dx equals integral 1 over x dx equals natural log of absolute value of x. Since x is a positive, we will get natural log of x. Substitute back here, e to the natural log of x equals x. Second step, we will use this formula to solve for y. X, y equals integral x, q of x is e to the x squared power dx. Since x squared prime equals 2x, multiply by 2, then 1/2 outside this integral. So we get this pattern, integral f prime of x e to the f of x power dx equals e f to the f of x power plus c. So we get 1/2 e to the x squared power plus c. Then for this equation, we need to figure out c. Since y of 1 equals 0, 0 equals 1/2 e to the first power plus c. So we get c equals negative 1/2 e. Then we substitute back. xy equals 1/2 e to the x squared power minus 1/2 e. Then we divide it by x both sides. Now we get two complex fractions. Drop down the denominator, e to the x squared power over 2x minus e over 2x. This is the final solution.